Thanks a lot for coming out to Signal, and thanks a lot for coming out to this talk. Again, Stuart Haley was going to give an amazing talk about how he's using Twilio at the Arkansas Children's Hospital. Unfortunately, he wasn't able to make it today. Last night, every single flight west out of Arkansas was completely canceled. There was no way that he could join us here today. So, unfortunately, I'm about half as smart as Stuart is, but I guarantee I'm twice as funny. And I'd like to today share a little bit of information about SMS for humans. That is to say, using natural language processing techniques to build better interfaces in the SMS apps that you build every day. Now, obviously, I'm kind of shooting from the hip here, so that is the grand total number of slides that I have for you today. But if it's okay with you, I'd like to just fire up a bit and cut some code and show you a little stuff with natural language processing. Does that sound okay with you? Awesome. Well, guys, I appreciate you coming out. I am Rob Spectre. I have the privilege of serving on the developer network crew for a company called Twilio, which you guys know about. And today I'd like to pop it open, a terminal, and just have a little fun with your text messages. I don't imagine you guys can see what's going on that screen, can you? Is that better? Is that good? All right, cool, cool. So, natural language processing. Who knows what natural language processing is? You do. What is it? What is it? What does it do? Yeah, it's an attempt by computer software to interpret the natural language that humans provide to it. That is to say, the actual phrases that you and I speak, it tries to interpret and take some sort of logical action upon it. Now, as it happens, in most of the software that you guys use, NLP is the central feature of a particular app, and often the only feature of the app, mostly because it's really, really hard, right? Natural language processing requires like tons of math and like probably a PhD from somewhere and a whole lot of academic effort that I certainly don't have. And so when you see it out in the field, usually the only feature that you see from a natural language processing software is the natural language processing itself. A good example is Siri, right? Like Siri is a natural language interface that you use to tell it to do something, and then it figures out something on your phone. But there's no other features in Siri because the natural language processing is so hard and takes up so much time. A lot of the time, natural language software can only do natural language. Now, as it happens, if you're a developer, and particularly, I might add, if you're a Python developer, you have before you a huge wealth of open source software that you can use to integrate small amounts of NLP in your applications to make big differences in the experiences for the users that you are trying to serve. Now, one of those interfaces is one I use every day, and it's text messaging. So if it's okay with you, I'd like to create a quick text messaging app, and then we'll start applying some NLP technique and explain what some of those are. Does that sound good? Cool. So I'm on my local machine here. I'm going to create a Flask application. We're going to be coding this in Python, but again, these tools are available for nearly every language under the sun. So if you're not a Python developer, hit me up afterwards and I can introduce you to some libraries that will help you in other languages, right? Obviously, we're at Signal, so we got to do something with Twilio, and we're going to have a lot of fun with it. We're going to create a new Flask app using the name of our script, and we're going to answer on an SMS endpoint some post messages that we're going to receive from Twilio. And in those post messages, we're going to respond with a little TWIML. In our first case, let's respond with, you guys are very kind coming after this mix-up in the schedule. So how about I give you guys a little prize for participating today, and we'll say, use the code word birdhouse at Bash tonight for 40 free tickets. So if you say birdhouse to some person in a red track jacket or running around that's Twilio personnel at Bash tonight, the big carnival for coders that we're going to have, as a thank you for putting up with this last minute change, we're going to go ahead and give you 40 free tickets that you can use in the prize booth. Does that sound good? All right, all you need to do is show them this text message, which indicates you are here. So if you guys want to whip out your phones, I'm going to cut a little boilerplate that's going to allow me to run this guy. And then we're going to be good to go. We're going to set our app debug to true because I'm live coding and anything can happen. Save that. And we're going to return the response object as a string, not the method verb. Cool. Let's fire up this application. And then we're going to use Shreve's excellent tool called EggRock to make it public. And we are going to drop that on this phone number on the screen. So if you guys go ahead and text 888-901-4831, that's 888-901-4831. Keep that number on your phone. We have some basic functionality up that'll give you guys a free ticket. So you show, or free 40 tickets. You go to Bash tonight, have a lot of fun at the circus, show this to any Twilio representative, and they'll give you some tasty tickets. Now, let's take what we started here and add a little debug logging so that we can share the text messages that we're receiving with all of you. So as we're performing this natural language processing, we can show you the language on the screen as you guys send in some text messages. Does that sound good? Cool, cool. So what we'll do is we will grab the body of each text message that's coming in by grabbing the body parameter in its post field. And we will use the logger for our app to send a message indicating the text message that we received. We'll create a new line and show you the text message that we sent. And then use some string formatting to send the body of the text message out. And then we will dive into our response and grab the body of the message that we're sending back to you. Cool. We will close that tag in its entirety. We'll also create a quick response back saying, thanks for logging this message. Cool. Save that guy, and we're good to go. So now, if you guys text in and just say hello to your fellow members in the audience. All right, looks like we have some natural language, right? Oh, I love you, Rob. That was very nice. That's so kind. That's so kind. Okay, so now we have some language to work with. Let's do some natural processing on it. So I'm going to expose you guys to a library that I love for doing natural language processing called TextBlob, and this is available for Python. There are obviously a number of different libraries that are out there, but this will make it easy to introduce some of the basic concepts of natural language processing. And with that TextBlob object, we'll create a text blob out of the bodies of the text messages that we're receiving. And then with that object, we can perform some very basic natural language processing. So first, let's respond with a message indicating some tokenization, right? So this is going to demonstrate the natural language processing technique of accepting some input and breaking it down into its individual linguistic components. So it'll take a big blob of text and break it down into its number of sentences and its number of words. So let's send a message back saying, you sent me this many words. And we'll format the string to include the length of how many words you sent in the blob. Okay. And so if we switch back and you guys send in a bunch of words, to that number, we'll see our little NLP script is now breaking down the stuff that you're sending in a few words. We can also, that's not the only token that's significant in the English language. We can also do sentences if we so choose. So if we flip back, we can see you sent me a sentence. I'll send you to. You can see we have a whole bunch of people sending me some gibberish, which is great. But we do, Eddie Zaneski, also very kind. Me dancing in your dreams is a little terrifying, but I appreciate you sharing that with the audience today. With this tokenization, this allows us to break down the language that we're receiving into its constituent components so that we can do things with it. One of the things that we can do with these tokens is classify them. Like, let's take all the proper nouns out of the language that we're receiving by going through each word, tagging it, that is to say, classifying it as a particular part of speech, and then return what we extract from the language that we are receiving. So in this particular case, we can grab from the tags, right? We can classify every token that our blob has created, and just grab the tags that have been classified as proper nouns. Does that make sense? So we're taking all the tokens in our blob, tagging them as parts of speech, and then just grabbing the ones that are proper nouns. And then we will return those in the response of our message. So now if you guys send in a few proper, ooh, looks like there are totally some proper nouns in there, and we were I'm afraid I totally mixed up, that's an off by one error. Totally mixed up the proper nouns that we're looking for. 0 is the word in this data structure, 1 is the part of speech that it represents. So if you'd be kind enough to send that message again, you'll be able to see a few proper nouns. It seems like Rick Astley is a proper noun. Nick Herschel is a proper noun. Big Daddy evidently is also identified in this particular case as a proper noun. Cool. Right on. Well, with these two techniques, the ability to tokenize language, that is, break it down into constituent linguistic components, and then classify what those individual items are. Then those are the two building blocks upon which most of NLP is based, right? Extracting patterns and then classifying them in order to gain wisdom of what you're trying to understand out of them. What's one like super popular NLP technique that combines tokenization and classification to do interesting stuff with text? What's a big one? Sentiment analysis, right? Like everybody hears a lot about sentiment analysis. And really, it's just taking these two things together and using them to divine some wisdom from the language that you're receiving. So let's do a little sentiment analysis now. We can grab the sentiment of the object that we've received, and we can respond with a message that gives you that sentiment back. And we'll just show you the raw data structure here so you can take a look at it. We'll grab sentiment. There we go. All right, so if you send in a new message that says, I am very happy, I am very sad, you will get a few responses. So what do you guys see? All right, so we got a bunch of language coming in. I hate you, as you can imagine. It's kind of a negative sentiment, and it's usually pretty clear. This does not suck. Obviously trying to confuse the language parser, producing zero polarity. But we have two values for each piece of language that we're receiving. We have one called the polarity, that is how strong the statement is in one direction. That goes from a scale of -1 to 1. And then we have the subjectivity of the sentence. That is the confidence factor, how confident the NLP parser is in the determination that it reached. So now that we've gotten this tokenization working, we've got this classification working, and we've applied it to a particular problem domain, the natural question is, how do we make this useful, especially in the SMS applications that we're building together? Well, one of the things I look at for a lot of the folks that we talk to at Signal so far are folks who are using SMS for doing customer service or some sort of customer-facing activity. How many of you guys are using SMS to talk to your customers right now? Well, you can imagine with a little bit of NLP, you can respond to your customers more naturally from your automated scripts by deriving some sort of intelligence on their sentiment, right? So if the sentiment's polarity was greater than 0, that is to say it was positive, we could respond with a message that says, "Rad, I'm stoked that you're stoked." Right? Our program could respond to the sentiment that they're expressing to us with a string that makes sense given the sentiment that they're providing us. Another one that we could do if they have a negative sentiment is to respond with a message that says, "Railer, I'm bummed that you're bummed." And if we couldn't divine what the polarity of the statement is, we could just respond with meh. Right? So let's send in a bunch of messages and see how our app responds. I've fallen and I can't get up. Meh. Howdy. Meh. Awesome. Rad. I'm stoked that you're stoked. Apparently it doesn't care about your butt hurting, but it does express some dismay that you hate hipsters so much. Pretty rad. Cool, so that's a simple way for your application to respond to the sentiment of your users using text messaging. Now obviously, what I'm seeing here is a lot of what they call false positives in NLP, right? Like there are a few in here that are not super exact. Everything is terrible and nothing is beautiful. Okay, that's fair. Let's see if we can find one that is like totally wrong. I love polarity. Oh, brilliant. I have gas. I am very hungry. Okay, let's take this one. I am very hungry. Now, the polarity is... The polarity of "I'm very hungry" is positive, right? But it's not like overwhelmingly positive, and the confidence of that isn't high. So if your application responds saying like, "That's awesome, man! That's super great that you're hungry," the user is going to, understandably be a little bit confused by that. So we can fix our application by making it a little bit more intelligent by not just looking at the polarity of the statement, but also looking at the subjectivity of the statement, right? And so we only want to respond with a response to the customer if we have a high degree of confidence that they did express a sentiment that we can recognize, right? So if they respond with a positive sentiment, we want to make darn sure that we know that's the case. So we'll add an and statement to our endpoint such that it will only respond if the confidence factor for the sentiment it analyzed is higher than 70%, right? So if I feel I'm 70% confident that the response was positive, then and only then will I respond with a positive message. So in this particular case, I can send the message, "I am very hungry," right? And instead of providing a positive response, we instead respond with the more neutral meh. Cool. Does that make sense? Cool. So that's sentiment analysis. Another super useful tool in natural language processing, and this will probably be the last one before we open it up to questions, is lemmatization. Who knows what lemmatization is? Okay, so lemmatization is taking the root of the word and defining what the core language behind that word is supposed to be. Let me give you a quick example. right? So a lot of us are working on apps that engage in commerce, right? And if someone wants to buy something, that's right, like the word buy is somewhere in the blob, you're going to respond in your text message with, great, I'll connect you to sales, right? If someone is responding with a sell in a blob, you might want to respond with, awesome, I'll connect you with a buyer. All right, and if we don't know what you sent, we'll say shrug. All right. So if we hop back and say, I want to buy a guitar, we get a message saying, great, I'll connect you to sales. And if I say, I want to sell some drums, we get the message saying that we want to connect you to a buyer. However, unfortunately, not all consumers want to participate in something in the current tense, right? So if we say, I bought a guitar and it is broken, right, the response that I'm going to get back is horrible from our application, which is saying that our application is going to respond with a shrug. It's not going to know what to do, right? Now, this is one of the prime examples of the difficulty of working with the English language, and one of the most difficult ways of learning working with the English language will be known to all of you who have adopted it as a second language, which is the case of the irregular verb, right? So both buy and sell, two very important words in the English language for commerce, are indeed irregular, meaning the present tense of buy and sell are spelled dramatically differently than the past tense of bought and sold. However, using natural language processing, we can make sure that we divine the root meaning of what our customers are trying to tell us by taking a look at the lemmas of the active verbs that they are passing us. So let's make this app a little smarter and be able to respond to both the present and past tense with the correct response for the language that we're receiving. And the first thing we'll do is we'll grab all the verbs from the blob that we're receiving if they are indeed one of the verbs that are tagged. So we'll look at all the verbs that are classed and make sure that we get all the verbs, right? If we receive a verb, we're going to take some action. If we don't get any verbs, we're going to cover that corner with a shrug. All right. And if we do have some verbs, we're going to go through each of them, and we are going to check if the lemma equals buy. We're going to respond, great, I'll connect you with a seller, or I'll connect you with sales. If the root, the core meaning of the verb is sell, I'll respond with killer, I'll connect you to a buyer. If we didn't know what it is, it'll be covered by this section. One last corner that we'll cover is we'll make sure that our response has some verbs in it. If it does not, we will say, I could not find any verbs. Well, with just a few more lines of code, hopefully we've made our app a little more intelligent, saying, I want to buy a guitar. We can see now that he sold a house, killer, I'll connect you to a buyer. I sold my guitar for nothing because Craigslist sucks. Great, killer, I'll connect you with a buyer. I want to buy a guitar, also connects you to sales. I'm selling my yacht. That's an example of the present participle tense. Also connects you to the correct resource. Cool, guys. So that, in a few lines of code, is how you can take natural language processing, something that is a very difficult computer discipline, through the use of open source libraries, and apply it to a problem domain that you guys and I use every day. So when you're thinking about the text messaging apps that you're building, I would encourage you to think beyond the basic all capital letters keyword, right? And instead, think about the wealth of open source technology that's around you, and use NLP techniques like tokenization, like classification, like sentiment analysis and lemmatization to make the interfaces that you are building for your customers via SMS a little bit more human. We only have about 3.5 minutes left for questions, but if you guys have any questions about NLP, would love to answer a few for you. Doug, are there PHP libraries for NLP? There are a couple that are pretty strong. I'd love to share them with you afterwards. I have them bookmarked on my machine. Any other questions for the group? Guys, thank you so much for coming out for my pitch hit. My name is Spectre. I'll be out in the hallway for the rest of the day.